In going about our everyday lives, we use a lot of water for drinking, washing, cooking, going to the toilet and much more. By using this water, it becomes polluted. The wastewater we produce is known as sewage.
Everything that leaves the house through the main drain pipe meets up with the sewer, right down here. In some places, it's a combined sewer, both wastewater and stormwater. In other words, everything from inside your house and everything from outside your house, rain, whatever, goes into a single combined sewer.
Offices, shops, factories and other industries. Together with rainwater that runs off roofs and roads, sewage is washed, flushed or drained into sewers. The underground network of sewers that collect all this wastewater and transports it to the sewage works is known as the sewerage system, and the area it drains is the catchment area.
All of it heads towards the wastewater treatment plant. In some places, the sewers are separated, one for wastewater and the other for stormwater. In that case, only the wastewater heads towards the wastewater treatment plant. The storm sewer goes straight to the river, untreated, because it's only water, right? Actually, no, it isn't. All the chemicals that you put on your lawn or the soap with all the phosphates that you wash your car with all head out in the storm sewer if you've got a separated system. Straight into the river. All the wastewater ends up at wastewater treatment plants. The purpose of these plants is to remove all solids and pathogens.
Let's look now at the sewage treatment process. At the sewage treatment works, the incoming waste passes through screens which remove large pieces of debris, such as plastic, paper and cloth. The liquid then flows through a number of channels which take out any grit washed in from roads. The sewage is then passed forward to large tanks. Here, fine particles sink to the bottom and form a sludge, which is regularly removed and further treated. Here we use bacteria to clean up the liquid sewage. The bacteria help purify the liquid by actively feeding on it and turning most of it into carbon dioxide, water and nitrogen. In biological filters, we encourage bacteria to grow in deep beds of irregularly shaped stones. Gaps between the stones circulate air, which lets the bacteria breathe and thrive as the liquid passes through them. An alternative to biological filters is a process called activated sludge, where air is bubbled through the sewage to encourage bacteriological growth. The air can then be pumped or entrained from the surface by rotating paddles. Either way, once the bacteria have done their work, the liquid goes into further settling tanks to remove the remaining particles, leaving clean water to flow to the river or, if necessary, onward to further treatment. To meet increasingly stringent standards, the cleaned water is often put through a further filtration process. Sometimes shallow gravel beds are used to filter out any fine particles. Alternatively, beds of reeds can also be used to give a final polish to the cleaned water before it's returned to the environment. This method is particularly useful in rural locations.
This is Beckton Sewage Works in East London, the largest sewage plant in Europe. Over 300 acres, fenced off from curious eyes, the sheer scale only comprehensible from the air. This one plant has to deal with the sewage and waste of all of North London, over 3.5 million people producing more than 12 million gallons of waste every hour.
This is Beckton Sewage Treatment Works in the east of London, and it's Europe's biggest. It was originally part of Joseph Bazalgette's scheme.
In the 19th century, sewage was simply stored here in tanks, then pumped out to the river at high tide. So you'll be pleased to know today's process is a lot more refined and takes just 4 hours for raw sewage to be clean enough to return to the river.
The first process happens here at the inlet works. Using these screens, large lumps like bricks, wood, rags are raked out.
Once collected, these large objects will all be washed and sent to a landfill site nearby.
They've even had half a car here.
Meanwhile, the remaining sewage passes on to the next part of the process into these primary settlement tanks.
Now, very basically, it enters at that end and flows relatively slowly this way.
Over the top of each tank is a moving bridge, which has 2 blades to remove solid organic material from the sewage. The top blade skims scum from the surface, while a second submerged blade dredges the heavier settled sludge from the bottom of the tank. All this solid sludge is then sent for further processing.
The remaining sewage then flows down this way towards the secondary biological treatment process.
And here it is. In these tanks, the sewage is mixed in with billions upon billions of bacteria, so all the dissolved materials that still remain can be biodegraded.
And pumping air from below at very high pressures causes the sewage to be saturated with dissolved oxygen, and this accelerates the biological breakdown.
It's brilliant.
Finally, the treated effluent is tested to ensure it's clean enough to go back into the Thames. Remember all of the solids which were skimmed off earlier? They're taken to a processing plant.
All sludges are brought to this filter press where it's dewatered, and the resulting sludge cake is incinerated, and that provides 75% of this entire work's power needs.
In our main wastewater treatment process, we took the contaminants out of the wastewater and concentrated them in the sludge. Now we've got to treat the sludge in order to make it less toxic, to destroy the pathogens, and have less of an impact on the environment. We also want to make it where it's easier to handle, recover some of the energy from it that we can use to power our wastewater treatment plant, and also turn out a beneficial product that can be used for soil conditioning.
Biosolids are the nutrient-rich byproduct of modern municipal wastewater treatment. Since the 1980s, the management of these organic solids has been increasingly focused on recycling. Efforts to control pollution at its source have dramatically improved the quality of wastewater coming into treatment plants. And the high-quality biosolids now produced by these plants are in great demand. The use of biosolids has come under considerable public and regulatory scrutiny. Regulations for wastewater solids are highly protective of human health and the environment.